படைச்சு. இந்த ஐஐசி ஒன்று ஆல்ரெடி வச்சிருக்கேன். நான் செயலி ஒன்று இருக்கலாம், ஐஐசி ஒன்று, அது ஒன்று. அப்புறம் வந்து யூடியூப்பு எஸ்எஸ்என் சேனல் ஏதோ போட்டாங்களா சார், ஏதோ ஒன்று பார்த்துக்க சொல்லி.
Hello.
மேம் ஹெச்ஓடிக்கு நம்ம சிசி போட்டு அனுப்பியிருக்கோம், பிசிக்கும் இவங்களுக்கு அதை வச்சு அவங்க மற்றவங்களுக்கு அனுப்பிட்டேன். மற்றவங்களுக்கு எல்லாருக்குமே போயிடுச்சு, ரிமைண்டர் போயிடுச்சு. 135 ரிமைண்டர் போயிடும். கார்த்திகை பண்ணிட்டாங்க. சிஎஸ்சி ஐடி பார்ட்டிசிபென்ட்ஸ் ஸ்காலர்ஸ் ஸ்டூடெண்ட்ஸுக்கு எல்லாருக்குமே திருப்பி மீட் போட்டேன் 12:00.
There will be more for the first virtual conference hosted by the Department of
Hello, ma'am.
Hello, ma'am. Hello, Professor Elizabeth, ma'am.
Hello, ma'am.
Yes.
Can you see me?
Yeah. Yes, ma'am. We are able to see you.
So can I present like this? I will share my screen.
Ma'am, we are yet to start the inaugural function.
Yeah,
We are starting at 1:45.
yeah. So no hurry. I
No
just
hurry.
I wanted to try if whether you can see my screen.
Oh, okay, okay, ma'am. Okay, ma'am.
Okay.
Please try.
You are visible and as well as audible, ma'am.
Please
Yeah.
give access for sharing.
Yeah.
Balli.
Yes, ma'am.
Now she can try, madam. Elizabeth, madam, you can try.
Madam, are you able to share?
I am I'm trying. I can't see the button. And
Oh.
let me
At the
have a look.
bottom, you have share screen.
Yeah, I know. I have clicked on that, but I can't find my screen.
Oh.
Sorry, what I do is I can see a lot of people here, but I can't see. Okay, now I have shared the screen.
But here it is not visible, madam. Can you share the slides
Lokeshwari.
form to me, ma'am, so that I will
Okay.
share?
Can you see?
Yeah. Now it has come.
Okay. So
Now it
you
has
can
come.
see?
Yes, ma'am. Yes, ma'am.
Yes. Yeah, it is
Okay.
coming. Yeah, it's coming.
Okay. Now I will leave it. I will wait for the section. Okay.
Yeah.
No hurry. No hurry.
Thank you so much, madam.
Okay.
Madam, we should stop sharing.
Okay. I'm trying.
Okay.
Just give me a little bit time.
Sure.
Yeah. And now I need to go back here.
Sir.
Your screen is visible. Yeah, now it has gone.
Okay.
Yeah.
Your work is going to fill a large part of your life, and the only way to be truly satisfied is to do what you believe is great work. And the only way to do great work is to love what you do. Steve Jobs. Very good afternoon to one and all present here. I am Lokeshwari, faculty from CSE department, and it's my great pleasure to welcome you all for the 4th edition of International Conference on Computational Intelligence in Data Science, ICCIDS 2021, conducted by Department of Computer Science, hosted by Sri Shivasubramanian Adar College of Engineering at Chennai, India. This is the first virtual conference conducted by our department due to prevailing pandemic condition of COVID-19. Hope everyone is safe and healthy in the post-pandemic world with the proper vaccination and precautionary measures to safeguard ourselves and also the people around us. So we welcome Dr. Shriman Kumar Bhattacharya, Vice Chancellor of Shivanadar University, our Principal, Dr. V. Annamalai, our beloved HOD, Dr. Chitra Babu, and all the faculty members and participants. You're most welcome to this international conference. Let's pray the Almighty and pay respect to our mother country. May I now request you all to raise your feet for the prayer song.
நீராறும் கடலுடுத்த நிலமடந்தை கெழிலொழுகும் சீராறும் மதனமென திகழ்வரத கண்டமிதில் எக்கணமும் அதில் சிறந்த திராவிடனல் திருநாடும் தக்க சிறு திரை நுதலும் தரித்தனரும் திலகமுமே அத்திலக வாசனை போல் அனைத்துலகும் இன்பமுற எத்திசையும் புகழ் மணக்க இருந்த பெரும் தமிழனங்கே தமிழனங்கே உன் சீரிழமை திறம்பியந்து செயல் மறந்து வாழ்த்துதுமே வாழ்த்துதுமே வாழ்த்துதுமே.
Thank you. May I now invite our HOD Ma'am, Dr. Chitra Babu, to deliver the welcome address.
Thank you, Lokeshwari. Distinguished Vice Chancellor of SNU Chennai, Dr. S.K. Bhattacharya, sir. Professor Elizabeth Chang, Canberra Fellow from University of New South Wales, Australia, who is our chief guest and keynote speaker for today. The conference chairs, co-chairs, faculty, and all delegates of this conference. I am extremely delighted to welcome all of you for this international conference on computational intelligence supported by Springer, and this is an IFIP event, International Federation on Information Processing. Since there are delegates outside SSN are also attending this conference, I would like to briefly tell about
You are muted. You are muted.
Unmute and talk, madam.
Okay. Are you able to hear me now?
Yes, yes.
Okay. Okay. I am sorry about it. Let me start again. Sorry about it. So, distinguished Vice Chancellor of SNU Chennai, Dr. S.K. Bhattacharya, Professor Elizabeth Chang, Canberra Fellow from the University of New South Wales, Australia, who is our chief guest and keynote speaker for today's session, the conference chairs and co-chairs, faculty members, and all other delegates of this conference. I'm extremely delighted to welcome all of you for this international conference on computational intelligence supported by Springer. This is an IFIP event, International Federation of Information Processing. Since there are delegates who are outside of this SSN who are also attending this conference, I would like to tell briefly about our department. Our department started in 1996 along with the inception of the college. I would like to tell that this is very special because this particular edition of the conference is happening in the Silver Jubilee year of SSN. This is the 25th year of since SSN started. And we have BE CSE program and also ME CSE program. And both of our programs are accredited by NBA under the outcome-based education. And our institution is also accredited by NAC with A+ grade. And in our department, we have very well-qualified and dedicated 34 faculty members, out of which 28 people are PhD holders and only 6 more, and they are also going to get their PhD soon in another couple of years. So the major research areas on which our department focuses are machine learning and data analytics, software engineering, architecture, and also in green networks. So we do have state-of-the-art infrastructure for performing deep learning related research and Boston Supermicro GPU server and several other servers with GPU cards for performing computationally intensive deep learning works. And our students have been consistently bagging very good university ranks, top 50 ranks. And in fact, a couple of times consecutively, they scored the top rank in all affiliated colleges. They came in the top rank. And our students, they get very good placements in dream companies like Google, Amazon, PayPal, Goldman Sachs, and similar kind of companies. And they also do get very prestigious internships in both academic related and also in industry kind of internships. And our department has student chapters of professional societies such as ACM, IEEE, and CSI, and several other campus chapters related to competitive programming. And in the past 4 years, our students have been participating very actively in the government organized Smart India Hackathon, and they have been winning prizes in the final round. And several other teams they are getting qualified for the grand finale. And regarding research, our faculty have been very actively engaged in the active research, and they have been publishing in reputed international journals as well as international conferences. And they are also active in filing the patents. And several of them have externally funded projects by the agencies such as DST, BIRAC, ISRO, and AICTE. And we do have MOUs with several companies with which we pursue collaborative research work and also consultancy work. We have been organizing FDPs, short-term training programs, workshops, seminars, guest lectures in all the emerging areas. And apart from this, we always, in the past 4 years, immediately after our first year students join, we have been conducting them an interesting event on computational thinking, in which we give them a lot of activities and involve the higher semester students as volunteers. Now, to come to this particular conference, this is the 4th edition of this conference. In 2017, the first edition was conducted. In 1950, Alan Turing, he asked this question: are the machines intelligent? So he had a Turing test for AI. If a machine, if a human being is not able to decipher whether he is talking to another human being or a machine, then probably that machine is equally intelligent as a human being. So this is the Turing test. And with our eternal quest for finding this kind of whether machines can think and whether machines have consciousness, so we have been doing this exercise of how we can make the machines learn, how the machines can actually feel the emotions, all these kind of, that is, the technology has been consistently progressing in this direction. Like humans learning through experience, now you are feeding this data to the machine, and through those historic data and experience, the machines are learning. So in fact, data is the new oil today in the digital economy, and data is the new gold. So with all this, we are analyzing this huge amount of big data, and we are kind of able to infer very valuable business insights. And that's why every business is after this, that is, they want to incorporate AI in AI, ML, and deep learning in some way. So especially the deep learning has achieved remarkable success and remarkable accuracy in the past few years, which the traditional machine learning was not able to achieve in complex areas like image or NLP or speech. Now this is able to achieve remarkable accuracy. So in all domains, like starting from healthcare, agriculture to manufacturing or retail, everywhere we are having applications of this kind of machine learning and data analytics. So it is very appropriate to have deliberations in this area, not only in the technical side of it, but also we have concerns like we should be using responsibly this AI and in a fair way, and we should be able to explain why we are doing something. So definitely this platform, this conference will provide all those opportunities to deliberate. I congratulate the conference chairs and co-chairs for their creditable efforts in organizing this conference. I appreciate all the faculty members of our department who have helped in reviewing the technical papers and have contributed to the conference in one way or another. I once again welcome all the delegates and I wish the conference a great success. Thank you.
Thank you, ma'am, for your kind words of welcome and briefing about our department activities. Now I would like to invite Dr. Sriman Kumar Bhattacharya, Vice Chancellor of Shivanadar University, to deliver the inaugural address.
Thank you very much. Very good afternoon to you all. Professor Elizabeth Chang, Professor of University of New South Wales, Australia, the chief guest of today's inaugural program and the keynote speaker for this conference. Professor Chitra Babu, the head of the Department of Computer Science and Engineering, my colleagues, dear participants, and the students who are attending this conference. On behalf of Shivanadar University, Chennai, and on my personal behalf, I extend a very hearty welcome to you all to this 4th International Conference on Computational Intelligence in Data Science, which is being organized by my colleagues from the Department of Computer Science and Engineering in association with the Springer International Federation of Information Processing. And this is certainly an area which is very important. The topic, as is being said, that computational intelligence in data science. I think today the whole world is looking after this aspect on computational intelligence. And as Madam Chitra has already outlined the aspects that are being looked into with the help of AI and machine learning. And I think possibly there is no boundary at this point of time. All disciplines are looking forward to the aspects on AI and machine learning. I am sure that all of you are aware of that today we are saying we are going through a phase which is Industry 4.0, the 4th industrial revolution that's happening, and where we are trying to make use of AI and machine learning to a large extent. And we expect that there will be interactions between the human and the machine and machine to machine kind of a thing. So in fact, I being a civil engineer, in fact, we are also looking forward to the aspects where from the maintenance point of view, from the design point of view, we are trying to make use of the huge data being acquired through the sensors, and to understand, make a decision and state that what are the kinds of distresses the structures are having and how those can be repaired and restored back. So in fact, today the scope is enormous, and I'm sure that this particular conference has certainly created a platform wherein a large number of researchers from all over the world have assembled over here. And, we are certainly going through a situation which is a pandemic situation. And this has given us opportunity. While we had difficulties on many ways, but this has created an opportunity to interact with each other through this digital platform. And I'm sure that a large number of people are able to attend to such kind of conferences. And I'm sure that this conference also is going to help a larger group of people in this particular area. Well, while I'm here in this inaugural program, I thought I will take this opportunity to let you know about the Shivanadar University, Chennai, which is recently been established through the Act of Tamil Nadu government in 2018. And now the university, in fact, is the first private university almost after 90 years It has been set up after Annamalai University. And well, the way we are trying to look at the formation of the university is that it's not going to be, again, a run-of-the-mill kind of university, but we are trying to create programs which will have some impact in the society. And towards this, the university has thought of to create 2 schools to start with, which is going to be started from the academic year 2021-22. And these 2 schools are School of Engineering and School of Commerce and Management. And under School of Engineering, we are going to have the Department of Computer Science and Engineering. And under School of Commerce and Management, we'll have Department of Commerce. And both these departments, in fact, Department of Computer Science and Engineering, will be offering 2 programs. One is BTech in Computer Science with emphasis on IoT, and BTech in AI and Data Science. Again, we are trying to create some kind of uniqueness in this system. And the Department of Commerce is going to offer, again, 2 programs, which is BCom in Professional Accounting and BCom Honors. So, again, as I said, that the university is looking forward to create some excellent programs which will be helpful for the student across the country. And I'm sure in the long run, the country is going to be benefited out of the programs. Coming back to the conference again, as I was saying, I'm sure that this particular conference is going to create a good platform for exchanging the research findings. And of course, the beginners, the students can listen to the experts, their views, their comments, and start working in the newer areas in which people are trying to look for the solutions. The country is looking forward to solutions to many challenging problems. And I'm sure that this platform will give you an avenue to understand those problems and how to find out ways to solve the problems. So once again, I extend a very hearty welcome to you all to this conference. And I wish that this conference will have a great success and people will learn more and more from this particular exchange. Thank you very much.
Thank you, sir, for briefing about Shivanada University, about the conference, and your blessings for the success of this conference. We are very much delighted to have you among us for the inauguration. Once again, our hearty thanks to you, sir. Now, I would like to call our conference chair, Dr. K. Vallidevi, to elaborate about the conference.
A very good afternoon to one and all connected here for the Springer IFIP ICCIDS 2021 conference. I welcome you all for the first virtual conference hosted by the Department of Computer Science and Engineering of SSN College. Yeah, the main objective of this conference is to help you connect the dots that matters to you. The world appears increasingly complex, and to seize the opportunities ahead, we need to be better in looking at the world from a wider array of perspectives. The growth of data, both in structured and unstructured form, presents challenges as well as opportunities for industries and academia over the next few years. With the explosive growth of data volumes, it is essential that real-time information that is of use to businesses must be extracted in order to deliver better insights to decision makers and to understand the complex patterns in it. God's greatest gift to human is intelligence. While human intelligence aims to adapt to new environments by utilizing a combination of different cognitive processes, artificial intelligence aims to build machines that can mimic the human behavior and to perform human-like actions. The human brain is analogous here, but the machines are digital. So it is hard computing. On the other hand, computational intelligence is the new concept of advanced information processing. Computational intelligence tools offers adaptive mechanisms that enable the understanding of data in complex and changing environments. Hence, learning computational intelligence in data science helps researchers to gain the knowledge and skills in order to analyze, interpret, and visualize the huge volumes of data which are complex in nature. The building blocks of computational intelligence involve computational modeling, natural intelligent systems, multi-agent systems, hybrid intelligent systems, etc. Data is the key ingredient for the development and enhancement of all intelligence-based systems, and blockchain secures these data. Blockchain, IoT, and AI can and it should be applied jointly. One possible connection between these technologies could be that IoT connects and provides data, while blockchain provides the infrastructure and sets up the rules of accessing those data, and the computational intelligence optimizes the processes and the rules. The theme of this conference is to explore computational intelligence and blockchain technology and how they can be used together. A few topics of interest of this conference includes blockchain-based AI and cloud computing, social networking, crowdsourcing and crowd sensing, deep learning in image processing, natural language processing, and speech processing. Hope this conference will provide an opportunity for the researchers to meet and discuss the latest solutions and scientific results and the methods in solving all the fascinating problems in the fields of big data, computational intelligence, and the blockchain technology. The conference program includes pre-conference workshop session along with prominent keynote talks and paper presentations. Mr. Sashikumar Venkatesh, Senior Software Engineer from Walmart Global Technology, Bengaluru, elaborated on the topic, how deep learning helps finding patterns in time series data, exploring with sparkling water during the pre-conference workshop session this morning. Tomorrow, on 19th March, we have a keynote talk on the topic Data Science for Social Good by Professor Ponnurangam Kumaraguru from IIIT Delhi. Followed by that, we have another talk on the topic Emerging Trends in Advanced Artificial Intelligence by Mr. Vivek Singhal, co-founder and Chief Data Scientist, CellStart, Bengaluru. On 20th March, being the third day of the conference, we have planned for a keynote talk by Dr. Garrick Hellman, Head of Research, blockchain.com from London. He will be sharing his knowledge about cryptocurrency and blockchain technology, past, present, and future. The next keynote talk will be by Dr. R.K. Agrawal, professor from Jawaharlal Nehru University, New Delhi, on the topic Deep Learning Models for Medical Image Analysis. And now, at present, we have our keynote speaker, Dr. Elizabeth Chang, professor of logistics and IT at the University of New South Wales, Canberra, Australia. And she has joined us now to deliver a talk on the topic Enterprise Blockchain, Trust, Security, and Privacy. And during all these 3 days, we would like to explore new ideas in the fields of blockchain, data science, and computational intelligence. We hope ICCIDS 2021 will serve as a forum to present the current works and as well as exchange the research ideas in these fields. Now, I welcome Dr. Elizabeth Chang, Professor, to next forward with her keynote talk. And thank you all.
Thank you, Validevi ma'am, for providing insights about the conference. Now, the most awaited session of the conference is the keynote talk by Dr. Elizabeth Chang. I would request our conference chair, Dr. R. Kanchana ma'am, to provide introduction about the keynote speaker.
Good afternoon, everyone. It gives me immense pleasure to introduce our chief guest, Professor Elizabeth Chang. First of all, I am very thankful to her for having accepted our invitation and deliver a keynote in our conference ICCIDS 2021. Professor Elizabeth Chang has been a professor of logistics and IT at the University of New South Wales, Canberra at Australia. She has more than 3 decades of work experience in both academia and industry. This includes 16 years of full professor at IT, software engineering, and defense logistics in 3 different universities in Australia. 12 years in commercial industries, typically working on large commercial grade system development. She has BSc, MSc, PhD, all in computer science and software engineering. Her key research strength is in large complex software development, including big data, trust, security, and risk. In the 2012 edition of MIS Quarterly, that is volume 36, issue 4, which is special issues on business research, Professor Chang was listed 5th in the world for researchers in business intelligence. She has delivered 60 plus keynote speeches, largely at IEEE conferences, and most recently in the area of big data analytics and business intelligence. She has published 8 books, over 300 international journal papers, and 300 refereed conference papers with an H index of 49 given by Google Scholar and over 14,000 citations. Together with defense, she has filed 2 patents in 1819. This is the first 2 patents in its 55 years of defense engagement between University of New South Wales and defense. Her achievement includes 30 competitive research grants, including 12 Australian Research Council grants worth $16 million. In the last 5 years, she was awarded 8 defense-related research grants and 2 ARC grants, total worth $3.85 million. She has supervised 52 PhD theses to completion, 21 masters, and 21 postdocs. She was the foundation director for Tier 1 Institute of Excellence on Digital Ecosystems and Business Intelligence for 6 years, and the founding director for a number of Center of Excellences, including the Center of Excellence for Extended Enterprises and Business Intelligence, Center of E-Commerce and IT Applications, Center for Logistics Informatics at other Australian universities. She is an IEEE Fellow and has been chair or co-chair for IEEE IES Technical Committee on Industrial Informatics since 2010. She is a chair of the IFIP International Working Group on Web Semantics since 2012. She is also an associate editor for IEEE Transactions on Industrial Electronics since 2007 and guest editor on IEEE Transactions on Industrial Informatics since 2005. Co-editor for International Journal on Engineering Intelligence Systems. Ma'am, we are really honored to have your talk in our conference. Now I request Professor Elizabeth Madam to deliver her keynote talk on enterprise blockchain, trust, security, and privacy. Thank you.
Thank you, Kanchana ma'am. Now the session is open to Dr. Elizabeth Chang.
Can you see my slides?
Ma'am, it is visible, ma'am. You can put it in presentation mode. Yes, ma'am. Thank you.
Good afternoon. Thank you for inviting me to give this keynote. And thank you for allowing us to share our work with you. Today's topic is focused on enterprise blockchain. And blockchain is a database, so I will focus on database. And it is an essential component for computational intelligence and data science. Without data, we cannot do computational intelligence or data science. So I'm focused on data today. And I'm going to focus on why it is important to have a trust, security, and privacy. This is not a new topic, but it is still an issue in our enterprise. So I'm going to go through those issues. It is not new in research, but it's still industry problems, major industry problems with regarding to enterprise databases, enterprise, information systems that is trustworthy, secure, and it's a privacy preservation that included as any information that kept within the enterprise. So my talk will be focused on number one, the data, the enterprise data. There are many data that can be used for computational intelligence, such as coronavirus, such as physics, space, cyber engineering, cyber security. But today, I'm focusing on the data related to enterprise, business. It's very important. As the example of coronavirus, if there is a virus, the whole city shut down, people lost their jobs, and it's affecting our life and affecting the national economy. So it is very important for enterprise, data to be managed so that it provides a very good track and trace, or contact tracing, so that you won't shut down the enterprise or business or national economy or the whole city. So that is why I'm passionate about enterprise data. Enterprise data could help to provide contact tracing. At the moment, if you look at the hotel is an enterprise, but contact tracing has not helping us to stop shut down the business or the city. So there are lots of work need to be done. Okay. So next, I identify industry problems in terms of what they think about trust, security, and privacy. It's very important in the enterprise setting that the employee or employer, they need to trust their information systems, and that they need to be provide workforce or workplace security. It is also related to us, okay? And trust is also related to us because database contains the information about us. And privacy is how do they share contact tracing at the moment they're using, some of them using facial recognition. And our privacy is not really, in control in our hand. And then I will say that when we talk about enterprise, what are the big data are coming from? Enterprise just a big Excel sheet. It's just and now we'll talk about how the computational intelligence can help business intelligence. What original definition of business intelligence is about machine learning for business intelligence or business analytics. It is about enterprise big data. But now we're moving to a blockchain, the new generation of database. But we have, 40, 50 years of business operations. They have lots of legacy database systems. How they can work together? Okay. Now, if everything in the blockchain sounds great, and if we have to use blockchain, how do we migrate the data to blockchain? And then I will give 3 case studies to demonstrate the effectiveness of blockchain if we can migrate or retire some of the old systems, so that we can utilize artificial intelligence, data science to help productivity and modernize the workforce and automate a lot of business processes. And then later on, I'll talk about blockchain implementation challenges, because we actually implement the blockchain. So, enterprise blockchain, I'm not defining the blockchain itself. I'm defining enterprise database that is done by blockchain. Enterprise blockchain is an enterprise data lake with a single source of truth. No database can provide a single source of truth, because they can be manipulated. They can be, changed at the back end. If you are an administrator, you can change it, but you cannot change a blockchain. So whatever saved in a blockchain, it provides a single source of truth. Then doesn't matter how many databases that work together. When you provide one report, it's one report, not a many reports that doesn't align each other. So it addresses the industry problems of trustworthiness of the data and the transactions, as well as accountability for human operators, because a blockchain stores a ledger. A ledger contains a data and transaction, and who saved that who did that transaction. So the operator ID is stored together with the data and transaction, which in the traditional systems, data stored somewhere, transaction stored somewhere, and there is no accountability can be traced within the system, because the data doesn't record the ID. The ID will be stored in a human resource database, which has limited information that doesn't really include the transactions they've done. So blockchain is the next generation of enterprise data management. And for future of our computer science, computational graduate student, data science student should move to help our business move to the new next generation of enterprise system management, data management. Okay, it will help modernize the workforce. You can see that many enterprises today are still using paperwork. And if you can utilize the blockchain, to help enterprise, at the same time you remove lots of manual process. This can be done when the time when you're available, when the enterprise is available, that you can help them to move data to blockchain. At the same time, you modernize the operation, reduce manual-based operations that actually modernize the workforce, because they don't have to do everything on hand, or slow, or access multiple systems at the same time. And this modernization or automation can be done within the enterprise or between the enterprise for both public and private sectors. Trust helps build workforce and consumer confidence, okay, through these database systems. And so that they are confident to carry out interaction transactions. and to reduce the risk of losses and the consequences of losses. Okay, so how much, if you want to book an airline ticket, how much you trust that website and you were willing to pay online to buy the ticket? Because also that if this costs $100 to $200, your loss is not much, and then you go ahead with it, and it seems it works. But in a business transactions, how much, for example, our banks, how much people trust our banks with managing our finance? Okay, and if you talk about the big enterprise, like working for government department, taxation department, healthcare department, and whether you are trusted database, whether you are willing to use it every day for your business and for the workforce, for the jobs, you may think that I don't care, but if you want to to be promoted within enterprise, you take a responsibility for the data that you're dealing with. Okay, and no one, in my opinion, the large enterprise, nobody at the workforce, nobody trusts the database because there are so many databases work together. For example, in America, the telco company typically have 20,000 databases running together at the same time. And in our Department of Defense, in 10 years ago, we have 4,000 systems running together for defense operation. And today, we're down to 2,000. And the different systems produce different reports. The security focuses on protecting the workforce and business. And this is also called physical security. And with the enterprise data sets, and for example, to use our SWAP card to go to work, okay, you are actually tracked when you log in and when you are, exit to the enterprise. So this can provide contact tracing for individual employees and how many people they associate with it, so that they can isolate the cases without shutting down the whole enterprise or without shutting down the whole city. And the privacy is, sometimes we our record is recorded in the database. Sometimes they use facial recognition, and we want to have control of the information what can be used, and to have a. Do we have some questions? Well, this is traditional databases in enterprise. And in that they are structured. And the big data was added in while we introduced, mobile phones and the internet, and we have unstructured data. Unstructured data is 95%, and the structured data is only 5% in today's enterprise data. And together, conjoined data mining, and it will help produce, the enterprise information intelligence. Okay, so I'm focused on data. So this is a unstructured data. Now, it's the only possible that use blockchain to manage such heterogeneous data sets. So, we can have a strategy to put the data, into a blockchain into the database, and they utilize the the big data in different databases, and we utilize artificial intelligence, and we visualize the results of data analytics. Okay, so it is about the big data that is essential for any computational work that will be done. Now with the backend heterogeneous database, that we can convert that into a blockchain, and then that will using a code concept, the blockchain itself is a data lake that allows heterogeneous data to be stored in the backend, and then we apply artificial intelligence and much more effectively and efficiently. So the enterprise cannot jump into blockchain just by tomorrow, because they have history, and they were having a business competition, business growing, data set together was growing, different additional database that inserted to enterprise. So everything's growing. So the database is getting bigger and bigger, and then the memory are getting require more and more. And then they traditionally 20 years ago we have a new concept called data warehouse, and then we have AI, BI, business intelligence associated with our data warehouse, and then that talk to the backend data centers. Okay, now because data are getting bigger and bigger, but then we create data marts, and that is the age before the blockchain. Okay, now this structure is not efficient, it's slow. And even though the whole thing was on the cloud, it was still slow because every transaction need to go back to cloud. It's very slow because it's 3-tier or 4-tier architecture. Now with the blockchain, that everything's moving to 2-tier. But with this structure, the traditional structure of enterprise data structure, that currently majority enterprises still in this structure, they're not moving to blockchain yet. There are lots of operational issues. All the systems are in silo, the database are in silo, and database are proprietary. They don't talk to each other, and you have to write a report, you have to manually extract the data, and then you could create error, human error, and it's time consuming, it's subject to manipulation or overwriting, and the report often rejected or people don't really believe. And such data are so fat and bulky and heavy and cannot keep up with the business growth. And enterprise, from operational issue to enterprise issue, they paid a lot of money. They could not change it immediately or timely. They are inflexible. They don't provide a single source of truth. They require expert to operate, and they are heterogeneous. They could be IBM, DB2, SAP, Oracle, all sort of data sets, and they are high cost and low return on investments. And most importantly, the vendor who provides this database has in control of the data, and therefore there's no privacy, security, and trust, because you don't really control your data. And if you want to integrate the data, you need to get data from different vendors. To procurement from different vendors is very difficult. Okay, and I'm sure that the people have a work experience will appreciate this is the difficulties that the government department and the large corporate that are facing right now, because this is the current database structure. No significant output that a enterprise has implemented the blockchain. Of course, the blockchain is new, and people don't really understand, a lot. But being a next generation of graduates from computer science, we can do this. So in flexibility and multiple data marts, no single source of truth, because you have multiple databases. Every database give you different results. Okay. and they, require expert to operate, and just can, managers cannot really use such complex database structure, because the output, the visualization is very good, but what it means, it is overwhelming and expensive, and continue consume a lot of enterprise, money to maintain such legacy systems, and the vendor in control, and most importantly, privacy, security, trust is still an issue. Okay, and now that since introduction of blockchain, it was not for enterprise. Okay, it was for the internet. So but now there are lots of researchers who work on how to use this wonderful technology and in the enterprise setting. Okay, and there are lots of jobs available in enterprise for this areas of work. The most important, the data lake will end the era of data silos. It will provide a single source of truth, because you dump all the data in the data lake. Okay, so data warehouse, data mart has no future. Interoperability should be forgotten, because they don't work with heterogeneous databases. With the blockchain, this is all the 10, 11 features of major features of blockchain. They are using a ledger, they single source of truth, they are distributed. So they have multiple copies, so that you cannot, one data center cannot just modify the database and achieve the result. And it has a public blockchain and a private blockchain and smart contract, and blockchain is transparent, so that everybody can access, share the information, and it's immutable. You can't change it, and it's traceable, and it's use consensus to govern the data, and your ID is not anonymous, and thus is a provider trust. And the distributed trust, the trust is not only just trust single systems, it's distributed, everybody trust. So it sounds like a music. Okay, now this is comparison between current existing enterprise database and what the blockchain can bring. And there are huge differences between the two. And the traditional database ERP, it is all relational, and blockchain can handle heterogeneous. You can be structured, non-structured, put it together. And it was a schema oriented, and then blockchain has no schema. And because it uses Elasticsearch, and traditional database is normalized. It's very difficult to normalize databases, therefore introduce errors. But blockchain reduce all of this headache that traditional database that give it to us, and create it as you don't have to focus on normalization. You just data dump and optimize, and this database can be scaled, scale out much more than traditional database. Traditional database cannot scale, and it is because it is open source, so it is low cost, and you can rapidly change, and you rapidly access, because you utilize SQL like queries. So you're not too far from your traditional learning of database, and it is replicated. Okay, not one administrator or one data center control all the database. It's distributed. So in the changes is modification, manipulation is impossible. And traditional database, technically, basically, they are SQL, they are non-SQL in the blockchain database. We call it rows and tables or columns. They call it collection and documents. And they have a fixed columns. You can't add a column just like that, But with blockchain database, you can horizontally, vertically scale up and add more data in it. and allow heterogeneous data types, bags and tables, arrays, document, images, maps, movies, all put together, which traditional database, ER database cannot handle those heterogeneous data type. And there is a replication and the consistency in terms of, access and query and using Elasticsearch, okay, and it help provide real-time analysis. Traditional database were slow, had to go back to cloud using 3-tier, and it will cost lots to update. So one of the effort is if a enterprise has very old, legacy in a business. For example, they've been operating for 20 years, 30 years, 40, 50 years. They have a lot of databases, and how to move the existing legacy database to blockchain. And they have to do this sooner or later because legacy systems, cannot keep up the pace with modern operation, modern demand. Okay, they're too slow because they need to join the table, they find the data, join the table, and bring them into another database, Excel sheet, and produce report. They're too slow. So the migration of to the blockchain is actually just the physical dump them into a data lake. Okay, you don't do schema matching. That is from a relational database to another relational database. Very difficult to do data migration. If the two database does the same thing, but the two different vendors, then you have no chance to do effectively. So interoperability or data, schema matching is not going to work. Our researcher already know this is a big problem. So that's why they developed the data lake concept. You just do the data dump. And then, the application by application, each application has a business process and policies. If they are important, if they need it, you convert them to smart contract. And then you build the data associated with it. So you do data migration, process migration, smart contract, and define roles and accountabilities. So that you have to build a new application because it's open source. You integrate and stitch them together with advanced AI, and the database is a data lake that you will be able to, you will find to use the blockchain is much efficient, effective. At the beginning, to jump to blockchain is not an easy task, but once you jump on it, you can do many things. Blockchain gives you a rigorous definition of how the data should be managed. You follow that framework, in the future, nice and easy. Not like a traditional database. Every database had different, definitions, concepts, terminologies, and have their own rules. Okay, so I give you an example how simple the blockchain that help the enterprise. Okay, a data model. When we focus on database, it's about data model that help us to understand our data. This is a traditional tax invoice. To represent this tax invoice, we have to have 8 entities to represent this one single tax invoice. One tax invoice, you just have a form, one page, but in database, we have 8 tables to be able to represent one tax invoice. Okay, then you can see you manage 8 tables. You define relation one to many, many to many, foreign key, primary key, and normally normalization. It is manage one form is much easier than manage 8 tables. So blockchain looks like this. Blockchain schema looks like this. It's called non-structured. You just pick up all the definitions here and list them here. Anything you're interested in the invoice, it's one table instead of 8 tables. You put them all together, different order, doesn't matter. And then what you do is you define anything that you are very interested in, you can do the search about it. This is called the indexing. So you said, I want to find it. Form the tax invoice. I want to identify tax invoice number. So you index this. I want to find how many item number, how many items. I want to find total price. These are only three things I'm interested in. Then I set up the index. Then I do search against this index. And you know, you don't save everything to blockchain, original data set, the whole data lake into blockchain. You save the hash. You know, hash is the DNA of that data lake. Data lake may not clean, may not have good quality, doesn't matter, but hash is. If we want to use a hash to reinterpret data, you get single source of truth. So you save hash, and hash is very small. It's just like a digit, and so therefore the blockchain itself is actually a hash, a database of hash that represent the database in the data lake. So you real data blockchain. Real blockchain is a hash database that in is as hash, out as a table. And then to access the blockchain, you have to have a public key and a primary key as a pair. So it doesn't matter it is in web interface on distributed network like a Bitcoin or thing. Everyone has a public key and a private key. So private key is yours, it's your private, nobody knows. But public key identify your ID, and that is how they manage whether you are trustworthiness, whether you are trust or you are not trust in the distributed network as an entity. How to migrate the data to blockchain? One way, what is the way we're doing is you open the application, you have an interface, you carry out some transaction, you save into database. Every transaction you conduct, you push that into blockchain. And then you can display the blockchain using your own interface, like a mobile interface, you know, like an advanced, graphical interface, rather than traditional tables and the views and very, overwhelming. And this is an example of the how we, use blockchain to advancing the enterprise data management. And one of the areas you do component by component, system by systems to update your system into blockchain. This traditional system, national vehicle management, has these processes. It is like a loop. You loop around, and it has a business processes. You look at, and then it has many people, many level of people accessing it. And every accessing is a loop, and they talk to each other, and they get signature. They go to the next operational level. The operational people actually does the transaction, and then they give it back to their division, and the data is actually saved as a like defense financial group, right? And then this is called joint logistic assurance lab, which ensure that the data use to validate, to audit the whole data, but audit the data incorporate the hierarchy of people, because they can access different level of authority. So the very, very time consuming of this process, lots of manual process. At the end of the day, the audit result is not good. Everybody not happy, because lots of process are manual. But you can remove all this process by over this process, the data look like that. Okay, you have some you know, signatures, you have images, you have you know, you enterprises store some of this data, and all of this data in the current form stored in enterprise database, or database only store data, and then those images and graph and voice and those things stored in the different folders. Okay, and the operational people has to every time has to access such a huge unstructured folders to be able to get the job done, apart from access structured database. Okay, this is just represent the complexity of current existing enterprise data structures. Now you can remove all of that processes by using AI. You don't have so many people manage the data, and then the whole of unstructured data, structured data dump into blockchain, and then you simplify, you automate the process, and you know, individual transactors can put using smart contract, and the transaction stored in the blockchain, and then they create a ledger. The ledger that ANAO is like an Australian National Audit. They audit the government department, and they need to have some data information, the defense, and you know, manage the data using blockchain, create a single source of truth, and they want to see the single source of truth. They don't want to access lots of databases to find what is truth, what is not truth. Okay, this is you can modernize the application with a graph image, and you can dump the existing database to this new application, and they access blockchain, and you can see how fast they can process your data is you know, compliant, is correct, is not correct, red is not correct, and it can identify the image, and the image is actually stored in the Excel sheets. No, image, the plates is actually numbers, is actually in Excel sheet. So in the Excel sheets, or in this form, they are associated with one entries in the Excel sheets. Okay, and the Excel sheets that you know is a table. They only store the data like a registration number, but all, you know, tax invoice. But all of these images and text invoices are stored somewhere else, not in a relational database. So in the blockchain, they can all stay stored together in data lake, and access is very efficient. And utilize a modern interface, and then you can do it in real time to compare that the table, each row of the table is actually indexed to the point to a real invoice or real image, and they correlate between the physical evidence and the data, and to see what is the discrepancies. And you know, a lot of this invoice or purchasing or procurement or buy and sales is the people use the paper, use piece of paper, enter them into the tables, but there is a discrepancy. They could have a discrepancy when they enter the data, so the data in the table in a row may not align with actual invoice. So you're using AI to validate evidence against the Excel sheet to see price there is same as the price you entered, to avoid any fraud. So the AI, okay, is very important in both structured and unstructured data mining, and the blockchain provides accountability, visibility, and you can utilize advanced mobile device. So for example, with the coronavirus, you don't allow to go to office, then your job is stopped. You can utilize, you can port application to mobile device or a laptop. They can work at home, almost the same as you work in the office. And it is achieve, better process, lower risk and accountability, and better asset management. Cost going down and the performance up, capability up. Okay. This is the second financial database auditing. basic financial data is recorded, what is expenditures, what you purchased, and the historical of purchasing, and keep recording all of this financial database. So it has a back end, and it has a front end, and it has some, statistical analytics. Okay, so with the blockchain, you don't have to replace existing financial database. You work in conjunction. Okay, so you not say that if you have blockchain, everything will retire immediately. They can retire slowly, one by one. Okay, so it's you have a blockchain work with existing enterprise environment, and then you utilize, all the, AI platform. That many tools available to help you to access the traditional databases and blockchain. And anything that come from blockchain, it is a single source of truth. And then you manage analytics, and you present it with the modern interfaces. Okay, this is the example. This is a traditional database. Okay, financial database. You can't, if you want to use blockchain, you have to migrate everything to blockchain. But you can still use the traditional database and blockchain. Each row represents either an invoice or a purchasing or transaction, okay, buy and sell. But it is indexed to a evidence that support this row entry. This row entry has evidence associated with it. So we use AI to access both structured and unstructured. This is structured and unstructured database to correlate them. And you can see immediately red is not, there's discrepancy. There's discrepancy in this column, but this one was okay. The green one was actually matching, complete matching. White one doesn't bother, but the red one, it is completely mismatching. For example, if the price is completely mismatching, it was say so 1 million here, you enter, $10. The actual evidence, or actual evidence is not exist, but you enter $1 million spent, but you don't have a evidence to support that record. That is mismatching, and it shows you which data in that row is not either discrepancy or is different from a from evidence. And yellow ones partially matching. Okay, and this is results that can be done with if they are all available in the data lake. You access the both database, and you done in a time of a few minutes, seconds, and it can be done in real time. The third one is I want to show the big data. It's very important, very good for computational intelligence and the data science students. Is that the future workforce will be. At the end of the day, we want jobs. We want the national economy continue going. With the coronavirus, we all suffered because the lots of job losses, enterprise shut, government shut your enterprise, government shut all the business lost, people lost a workforce like us, lost the jobs. Okay, so it is, but we can utilize enterprise data for contact tracing. And we can pinpoint individuals. We don't have to shut the whole business. We know, and at the moment, the contact tracing was so bad, they just say these guys came there for 2 hours and then shut down the whole business for 2 weeks or something like that, or the whole city. So at the end of the day, the enterprise data provide very good contact tracing. They don't use enterprise data for that because they create something like a mobile phone QR code, and where you go, you enter your detail. But enterprise has data, big data, particularly when you enter to some enterprise, you need a swipe card, student card, whatever. That gives you the contact tracing opportunities, and you can use that data for contact tracing. Okay, so this private security energy, this are all already done in the existing systems, like smart homes, securing privacy. But just to talk about contact tracing, we have developed the tool, the box, okay, that can do the hand sanitizing, but also image of your hands, so that you clean your hand when you enter the data, but we able to keep your access. You can, this access can be hand image or can be swipe card, but swipe card is contact based, and this is contactless access control, so that you don't touch any surface. You don't touch any surface. You just put your hands in, or and then you use. This is better than facial recognition, because you get photographed all the time. That is we're not comfortable with that. But not like Japan and China, they just photograph you anyway. But in a Europe country, they not America, they against the facial recognition. But with every entrance, that you either use contactless swipe card or mobile phone or hand scanner, and then the enterprise keep your record in, and what time you're out. And this data is already in the enterprise database. If you go to any government department, you have to have this one to get in. Otherwise, you won't be able to get in. And for any big corporation, you have to have access. So they have this data available. You can use this for contact tracing and to avoid shut down the business. And then you have interfaces, the mobile control, remote control or mobile control of the information to look at it. You not just have to go back to the data center to manage all the data. You can utilize modern technology to access the data and for contract tracing. Okay, and the examples, a person could running around in different buildings, and then you have this, you record it by the swipe card, and you will know these two people was together at that time, at a particular time. You just isolate them instead of shut down the enterprise. Okay, so the system you can provide the warning systems, you can provide the early detection systems, and that is you protect the workforce. Okay, it is protecting the jobs, protecting national economy. So this we developed this technology called hand sanitizer, together with contactless hand imaging or hand scanner, that without swiping cards or key tap in or push the button or fill up the forms, and protect the workforce, cannot transmit virus without you don't touch a surface. So there are different type of algorithms, machine learning, multiple convolution algorithms. We utilize those data even for just normal analysis. Enterprise has big data, just they don't use it. Okay, and you can use swarm intelligence. You can use evolution algorithms for coronavirus analysis, contact tracing. So this is some experience of implement the blockchain. I'm nearly finished. So the key issues, it is you have to implement a private blockchain for enterprise. It's not public blockchain. And the public blockchain and the private blockchain implementation different. For enterprise, had to have a blockchain, private blockchain. So that is different. You need to overcome. There are not a lot of. It is open source. It's for public blockchain, but you have to convert to private blockchain. Then you have to address some of these issues. Public blockchain that are already available open source is look like that. The people are peer-to-peer communications. Enterprise, it doesn't look like that. Enterprise has hierarchies, and you need to address this. Okay, in a public blockchain, that they only record the transaction, how much money you have, and who is the participant. But in a private blockchain, you actually, recording. It just transaction time and anonymous participant is not enough. We have to look at many other informations. the group of people, the division, the individuals, the photographs, and how much dollar, and all of and they're able to configure that, and they are whether they are using mobile device did it or what they have done. So the people and the roles are important in the private blockchain, because they are not just trading the dollar, they're doing transactions. So you need to record more information than just a public blockchain. In the traditional, the blockchain, public blockchain environment, you're basically tracking around the network, but enterprise has the internal network as well as external network. So you need to track inside and outside the enterprise. So that need to be taken care. And internally is distributed, externally enterprise in communication, supplier, customer itself is a network, and this network is a distributed network. Internally, different division, different department, you still have to set up distributed network so you can replicate the database. So this is a challenge within enterprise to set up distributed. You can set up distributed databases, and this, but a little bit of work that you need to take care of, and in the public enterprise, once they have the smart contracts is through whether the user agree or not. They have a voting systems. They have consensus. They all agree. Smart contract is created, but in private enterprise, people can't change the policies. So you have to fix the policies. That is what you do. This is enterprise. That is what you implement. So you don't give that flexibility. Public blockchain is manage the smart contract at the back end, but with private blockchain, you can have the front end database, because you're dealing with blockchain. You have to save them, in the local blockchain, so that you can submit it. The transaction sometimes can be done without the internet, but you done the transaction, you done locally. You have a wireless locally, but it didn't connect to the internet outside. Particularly in the government department, sometimes the data that for example, Department of Defense, inside the base, it's wireless works, but it doesn't connect to the internet. So your data capture has to be stored in the front end of blockchain, so that the smart contract in the both sides, front end and back end, and the traditional, the public blockchain running on the website, start from scratch. But enterprise blockchain, you have to work with the existing legacy systems. So it is not, it is data-like. It's an easy concept, but it's not as just blockchain straight away. You have to, using a blockchain, work with the existing legacy systems. And the blockchain, and then public blockchain, you don't have to worry about legacy systems. But in a private enterprise database, you have to worry about all other databases that are structured. There are some other things, because your blockchain, you don't replace the whole thing in one go. You can retire system slowly by slowly if your blockchain is sufficient to take up the job. But blockchain can work side by side with legacy systems, and in the public blockchain, that everyone can work at any times, 24 hours, 7. In the private blockchain, there is a workflow you have to follow. You can't jump, in between. It's like a flow chart according to the time and the space and the passing information, signature, and go back loop. It's a work process. And the private blockchain have to have a public and private key permission. Okay, and the further challenges is in the private blockchain, the public key infrastructure itself still centralized. So somebody can who has administrator access, they can go there and grab all the public key. And then so that to avoid that process, that how you store the public key to address the public key infrastructure, and then add your own private key, how you want to store it front and the back ends. We store them in the back end, and so that to avoid insider threat. Insider means administrator's threat, because he has access to the database. You could get all the public key, and if you have a partner network, supplier and customers network, and it will, everybody in the network, he know the public key, or at least the public key for your organization. So we are also working on we have been successful in automated smart contract generation, and we are already work on to overcome the issues of multiple blockchain that are running together, because in the business network, it's not just you only have a blockchain yourself, and other people have a blockchain and how they work together, and because it's open source, there's a limited standard available for that. So I've said that the big data enterprise blockchain sounds like music, and it sounds great, but there are lots of work to be done in the next generation of computer science graduates. Thank you very much for your attention. Oh.
Ma'am, you have a question in chat.
Yes.
What effect GDPR compliance rules have on blockchain implementation?
Can you repeat again?
In chat, our HOD ma'am has asked, what effect GDPR compliance rules have on blockchain implementation?
GBS?
GDPR.
GDPR. What, can you explain the definition of GDPR? What, can you define the GDPR?
General data protection rule. General data protection rule.
Okay.
So the compliance rule on blockchain implementation. How to protect the user privacy.
Yes. If you have, if you have swap cards, okay. If you have swap cards, your data stored in the central databases, and the people can use this data. But and you can't stop that. People can use data, enterprise can use data, enterprise can sell the data. So there's no privacy about that. Okay, where you've done your work, how many hours stays. So the solution from a contact-based to contactless base, they use facial recognition. And the facial recognition is a very intrusive privacy. So everywhere you go, you use a face as a key. And in Japan, in China, in a train station or in a rail station, they just use a face to pay the ticket. So you just walk straight in, okay? But that is intrusive privacy. But with any data that if you have swapped it and you're saving to blockchain, and the blockchain and the hash of that data into blockchain, that blockchain cannot be decomposed by any intruder. Only people have a private key. Only you have a private key. You can have a look at your data, but nobody had a private key access the blockchain. Blockchain cannot be accessed without private key. And then if you have your own information, and if you use blockchain, it will say as a hash into the blockchain. And so that's why the blockchain itself is provide this privacy that people cannot access. At the moment, the enterprise, their data is stored not in blockchain. And everyone, whoever have a database access, they can have the data and have your privacy, have your private data. You have no control of that. And the important is the hash. It's the hash that is stored in the blockchain that is provided, and then nobody, can access it without private blockchain. So you actually protect your own. You can have your own. You can decide when you want to share your data, but you have your private key, and you can access blockchain, and you can retrieve all your information, and then give it to a medical doctor to look at it or whatever. Because of the data storage is hashed, and that provides privacy.
Ma'am, there is one more question in the chat from Pumuta. How does blockchain support for educational domain?
I think it could have many applications. Education is a big word. They have many dimensions. An example of in education sector, the schools. In the coronavirus time, the schools are shut, and now the student go back to school. Contact tracing is very difficult. So if you have some mechanisms to have contactless entry in the records and store them in blockchain, it will help school to keep running, because this contactless, access control will help contact tracing. And we don't have this in the school, okay? And it will be a big data. But this, but there's nobody, there are access control. You can have access control by swipe card, by mobile phone, by key, or by fill up the form, dial, the dial you can go in, or by your face. But in the school, in education school, we all care about children. In the school, they don't have this. So you can have facial recognition. Facial recognition could have temperature. If you have temperature detected, the sensor, or you have this, like we are developing this device. You put your hand there, you get some gel to clean your hands, and then you go in because they recognize your hands. Okay, there are many hand recognition devices already used. Over 10 years, Fujitsu has a palm one scan, and the wireless Amazon.com, they have all of this hand recognition device. You don't have to develop anything from scratch. You can use it to help school a lot, and to have help kids, because it is for them. It is for them to be healthy, and you contact tracing, and using blockchain is more efficient, because blockchain is small. It can run, at edge, computing at edge, not have to be in the cloud, and it's not huge database, because it's hashed everything. You can't directly interpret the hash. And this is one thing very important for school at the moment. And the world, maybe different virus we're going to extend in the next years and years. We don't know. But somebody had to do something to protect children to get infection from a surface. So contactless entry for school is very important, and contact tracing using big data, because when they access school, they should have some control. So you can individual where it goes to this building, that building, it have access control, and you can trace them, whom they contact. You don't have to shut the whole school, or whole city. That is one thing for education. And there are many other applications that you can use for you teach blockchain. No school, no university now teaching blockchain because it's new. But you know, if you develop a team that trial some blockchain, start teaching blockchain, your next generation of kids will teach blockchain, and they will know. I have a group of young people. They are in their 20s. They only finished the degree, undergrad degree. I give them blockchain, jump on it within 2 months. And within 3 weeks, they can get all the public blockchain running. And then within 2 months, they can develop some private blockchain and show me. And this has been occurred for 4 years. All the young people can jump on it just like boom, like that. For us, you know, we have a little bit difficult to switch our mind to accept the way the blockchain does. But because we have experience, we appreciate the blockchain, the way it organized. It is through the, you know, the intelligent people that knows what the traditional database difficulties are and develop this blockchain. This is a future database. Sooner or later, we will use blockchain for everything. And people like us need it, workforce need it, workforce want to provide it. Later on, you will see the CCTV will be everywhere. And, you know, the enterprise will have facial recognitions. And if they can use blockchain, it will provide some degree of privacy. And it's an area that could be worked on. No solution yet. Just the previous questions. Have I answered your questions?
I have responded yes, ma'am, in the chat window.
Yeah. Okay. Okay, I see. You know, I like to talk a little bit more about the data protection regulations. There is no standard at the moment, and the data protection could be top secret, you know, secret protected, or general, you know, limited, you know, restrict the different level of data protection based on your roles. They give you different access. And there are policies changes on those all the time. And the data protection regulation that should cover the blockchain. And because blockchain is new technology, people don't want to touch it. And until, you know, the whole world jump onto blockchain. If you look at the UAE, and they jump into blockchain at 2020, they said 5 years ago, they said the whole UAE will move to blockchain. Government will move to blockchain. The US government also, the US government all moved to blockchain. That was like 5-6 years ago. At that time, we heard about what is blockchain, you know, and why the blockchain is so important. So general data protection regulations keep changing. Different country has their different roles. And I think data protection is related, you know, data, you know, abuse, and data protection related to data quality, data protection related to data cybersecurity, and data protection related to physical security, and data protection related to people's and their roles, and they use their role, you know, relative to the data they can access. If they access more than what they have defined, so data protection is not you know, compulsory if you implement blockchain to know about data protection, but people must be learning the rules of data protection in your organization, what you can share, what you can't share, what can you access, what you can't access, what if data they give it to you is a secret, how you can store them so that you make sure it's secret, and the data that you access, you have USB, you don't have USB, you copy them to one machine to the other machine. If you have a secure room and you enter secure room, all of that involve data protection. But at least the blockchain can protect data. All data, if somebody gave you data is a secret, you put them into blockchain. And then when the audit comes, you say it's on blockchain. And then use that to provide, the evidence that the data is private, because blockchain keep the signatures, who accessing it. You don't have private key, you cannot access. Because the data is a ledger, it's a traditional database, maybe only data, and in the database, transaction in applications, sometimes change the data is in here, but the transaction, how the transaction worked, it did not record it. And but the result of data is updated, and the people who operate on this transaction is not recorded. With the blockchain, the ledger describes that automatically. You don't have to develop a ledger. It's already there. You just use it. It automatically records the ID of the transactor. So you can trace. Who did this dumb work. You can trace there was a big losses in $2 billion. Who is responsible for that? Or there is a fraud, $2 million. Who did that? You can trace if that is identified, if that is an issue. And blockchain create a ledger. That ledger is a record of data, transaction, and ID. And this is primary information, plus all other information you want to store in the ledger. You can define what you have, but these three components is primary data. You can also add other data in it. Am I answer your question? Okay, I see some. How does blockchain support education domain? Some European Union is very fuzzy about data protection. It has constraint on blockchain based on solution. And this is what I was trying to find out. But it's a different issue. It's a different issue. If data protection regulation and policy is a cybersecurity issue, okay, you can study that. It's not really, that the blockchain is a tool. We just use it. It does the encryption and encrypt all the data, okay. But if you use blockchain, and if your room is not secure, or if and blockchain at least give you some, but not all the people. Sorry, the lights switched off. But the blockchain, the immunity, provide immunity, and the but practically the blockchain that people were talking about blockchain has some issues, but they have never been able to, in the public blockchain, they have never been able to broken the private wallet. No, the blockchain itself never broken, but they can steal individual wallet because your private key is lost, or you lost a private key, or somehow you didn't store properly. But they never be able to broken the blockchain itself and then in the distributed network. They never. There were lots of things about the blockchain, people stealing the money, but it's only private wallet, but not blockchain network, and data stored in the blockchain. I think the immutability is publicly recognized, and the right to be forgotten, I'm not quite sure, by the policy. I would say data protection, data security, data quality, data security itself is a cybersecurity research area. There are lots of people studying the regulation, the policy, the standard, and all of that. And I think blockchain is more like a database implementation challenging issues rather than research it, because we don't develop blockchain. It's already there. You develop policy around it, but in fact, enterprise has not yet implemented successful blockchain. So many policies, regulations around the data protection. It's very difficult to overcome the documentation among different policies. You can have an architectural policy, you can have network policy, you can have access policy, you can have system policy, you have data policy. They could develop 20 policy. I think in our organization, we had at least 20, 30 different policies just on data protection. And it is really, really, I would say that there's no standards. So it is really wasting a lot of time to read those policies. They're not quite clear and sometimes subject to interpretation. So this is, I have students study in the policy and try to automate the policy and try to look at all different policy and the regulations and create a unified regulations for Department of Defense. So it's an area that involves lots of documentation and legal and law use of data. But I would say we are in the open society and we are in the open economy. We should allow sharing data, and blockchain allow you to have this visibility and sharing of information, because when you share, people modify, because you have DNAs in your database. So you don't want to share, and if somebody modified it, you will be able to check. So we should not protect too much. We should open and sharing.
Thank you, Madam, for your detailed explanation. Thank you very much. I appreciate it. Thank you.
Thank you very much. Thank you for having me.
Thank you, ma'am, for your informative talk. Thank you so much for giving this useful talk. I hope the audience would have got the most. Thank you so much.
Thank you very much. And you can always contact me if you have any questions.
Yeah, definitely.
Thank you.
Thank you, Professor Elizabeth Chang, for briefing us the security and privacy issues in blockchain, case study and implementation challenges. Really, it was a wonderful session. Hope the participants will take your valuable knowledge and proceed it to the next level. May I now request all of you to turn your camera on to take a snapshot.
Thank you.
Thank you.
Thank you, participants. The link for filling the attendance and feedback has been shared in the chat box. Kindly fill the feedback and provide your attendance.